For almost a decade, scientists chased the source of deadly new virus through China's tallest mountain and most isolated caverns. They finally found it here, in the base of Seattle Cave. The virus in question was the coronavirus, thus called an epidemic of severe acute respiratory syndrome or SARS in 2003. Coronavirus are a group of viruses covered in little protein spikes that look like crown or corona in Latin. There are hundreds of known coronaviruses. 7 of them infect humans and can cause disease. The coronavirus SARS-CoV causes SARS, MERS-CoV causes MERS, and SARS-CoV-2 causes the disease COVID-19. Of the 7 human coronaviruses, 4 cause mild, highly contagious infection of nose and throat. 2 infection the lung and cause much more severe illnesses. The 7th, which causes COVID-19, have feature of age. It spread easily, can severe impact the lungs. When the uninfected people cough, droplet containing the virus spray out. The virus can infect a new person when the droplet enter their nose or mouth. Coronavirus transmits best in enclosed spaces. People cold weather keep their delicate casing from dying out, enabling the virus to survive for longer between hosts. While UV exposure for sunlight may damage it. These seasonal variations matter more for established viruses. But because no one is yet immune to a new virus, it has so many potential hosts that it doesn't need ideal condition to spread. In the body, the protein spike embed in host cells and fuse with them, enabling the virus to replicate its own genes. Coronavirus store their genes on RNA. All viruses are either RNA viruses or DNA viruses. RNA viruses tend to be smaller with few genes, meaning infect many hosts and replicate quickly in those hosts. In general, RNA viruses don't have an approved threading, whereas DNA viruses do. So when RNA viruses replicate, it much more likely have the mistake called mutation. Many of the mutations are useless or even harmful, but some make the virus better suited for certain environments, like a new host species. Epidemics often occur when a virus jumps from animals to humans. This is true of the RNA viruses that caused the Ebola, Zika, and SARS epidemic and the COVID-19 pandemic. Once in humans, the virus still mutates, using not enough to create a virus, but enough to create variation of strains of the original one. Coronaviruses have few key differences from the most RNA viruses. There's some of the largest mean they have the more genes that create more opportunity to harmful mutation. To counteract this risk, coronaviruses have unique feature, an enzyme that checks for replication errors and correct mistakes. This makes coronaviruses much more stable with a slow mutation rate than other RNA viruses. While this may sound formidable, the slow mutation rate is actually a promising sign when it comes to disarming them. After infection, our immune system can recognize them and destroy them more quickly if infect us, so they don't make us sick. But mutation can make a virus less recognizable to immune system and therefore more difficult to find out. They can also make antiviral drug and vaccine less effective because they tailor very specifically to a virus. That's why we need a new flu vaccine every year. The influenza virus mutates so quickly that new strains pop up constantly. The slow mutation rate of coronavirus means our immune system, drug, and vaccine might be able to recognize them for longer after infection and therefore protect us better. Still, we don't know how long our body remain immune to different coronaviruses. There never been an approved treatment or vaccines for a coronavirus. We have been focused on treating the ones that's cold, and those scientists began develop treatment for SARS and MERS. The epidemic ended before the treatment completed the critical trial. As we continue to encroach on other animal habitats, some scientists say the new coronavirus jumping to human is inevitable, but if we investigate the unknowns, it doesn't have to be devastating.